Hi everyone, thank you for attending this session. I am Aishwarya Naresh Reganti. I am an applied science tech lead at AWS. And today I will be talking about the evolution of automation as a space and how RPA or robotic process automation and AI agents can transform this space. Today's agenda is pretty much this, right? We'll understand what agents are. Most of you have heard the term, but I want to make sure all of us are on the same page. And then explain how RPA as a concept and agents are different to each other. And finally, see how both of these can actually be put together in order to improve the automation space. Now, agents, the term has been floating around for a while now. And if you kind of technically see what agents mean, these are systems where LLMs are kind of the brain or the center, and they are given access to tools which are basically APIs or any kind of um, external websites or things like that, or even a Python script can be a tool. And they also have access to memory, which is basically some kind of data or some kind of historical occurrence that is kind of stored in a database format. And they also have access to planning, or more of they are prompted in order to do planning, and they kind of use all of these components in order to complete tasks end to end, right? So if you had to put it in a single sentence, so AI agents are pretty much LLMs with access to tools, memory, they're tasked with planning and executing codes, right? If you kind of think of it, all of these components, the connections between an LLM and all of these components is pretty much engineering. It is kind of orchestrating all of these things together, right? And kind of make this concept a little more clear. Um, this is a good diagram to explain it, right? Now, let's say a user comes to an AI agent and says, generate a quarterly performance report for our sales department, focusing on revenue growth, right? Like, this is a higher order goal, which requires breaking down the goal into smaller steps and executing it. And what the agent does is basically first generates a plan. It says, okay, in order to do this, I probably need to generate a plan. I need to query a database. I need to analyze what the database is sending me back, and then analyze maybe previous year reports, and then come up with a final response, right? And since the agent has access to tools as well, it can and tools here can be external databases, right? And what it does is says, I'm going to generate a SQL query in order to get information from my database, and let's say the database comes up with an answer. It probably says, select sum of sales amount where sales data, etc., in order to identify what is the performance. And then let's say the database comes up with some response, right? And finally the agent uses that to say that I'm going to use this information to generate a quarterly sales report. But how do I know what format of sales report should be generated? It picks up from memory, right? Historically the company has been using a certain format, and it says, I'm going to pick up that and use that to generate the final sales report, and says, okay, here's the performance report that you have. So this is how agents handle tasks end to end. It is the LLM still, or the AI model, that's kind of sitting in between all of this, but then it's connected to multiple different components in order to make sure that they come together and do a task end to end. Unlike just prompt engineering, where you're or interacting with AI models using prompt engineering, where you're probably having one-on-one conversations. Here it uses other external APIs and tools in order to complete your task end to end, right? Now I want to quickly give you an overview of robotic process automation, which has been existing for a while now, right? And the idea for RPA is basically it automates a bunch of repetitive or rule-based tasks, and it tries to mimic human actions on digital systems, right? Now, the key characteristics for RPA itself is it was always designed for predefined rule-based workflows, and it's very deterministic, which means it executes tasks exactly as programmed and cannot adapt. It cannot learn or adapt beyond programming logic, beyond the code that's being used to write that. But this was exactly what RPA was being used for. We find tasks which are being done repetitively by humans, no creative processes being used, no decisions being made, and we kind of automate them with code in order to make it simpler, right? If you kind of think of how RPA systems were historically built, you can kind of put them into three different steps, right? The first one is your design phase, where you identify a process that's being repeated pretty heavily, and then you come up with a solution architecture as to how you want to automate this. And then there's this execution phase where you probably have this robot, or you have an API that's kind of sitting, and then you have the testing phase or the deployment phase, right? Each of these are, huge topics in themselves, but I'm kind of keeping it high level so that we can cover more about the important concepts, right? And then there's your monitoring phase where you've deployed this, you've deployed an RPA system, and you're doing some performance tracking. If there are incidents happening, you're doing resolution of those incidents and kind of using this pipeline to improve your system, right? Now, in order to kind of just walk you through an example of how a typical RPA system would look like, let's say we have a automated inventory management system. You want to automate stock monitoring, order generation, and timely replenishment, right? This happens all the time when you have these inventory management in large warehouses and these kind of things. And in the design phase, what one would do is to say that if the stock count of different products reduces less than threshold value, probably you have sensors placed in order to understand your stock count, or you have people manually updating this and things like that. Then you say, create a new order, and then you notify the suppliers, saying that the stock count is reduced and I want 50 new orders of a particular thing or something. This is kind of the design of how you would think of it. And then you'll probably go to the execution phase where you would do three things. One is to retrieve inventory data. You might have an inventory system which can check stock levels. This can be manually done, the stock level updation, or it could be done through sensors and things like that. And then you generate a purchase order, like you use templates that have been existing previously, and the system can generate a purchase order which compares with thresholds, fills in supplier details, and then sends an order to the supplier, right? And then in the execution phase, you kind of build all of these components, deploy and validate them. And then you probably have a monitoring phase as well. And monitoring is almost something that's always being done in the background, but I'm just explaining it because this is also one component of building an RPA system where you kind of track performance. You're probably monitoring stock updates, you're logging replenishment timelines and things like that. And you resolve any incidents that come with this RPA system, right? With predefined rules. Anything that seems critical that the system itself cannot handle, you're probably escalating it to a human or something. Now, this is a typical workflow of how an RPA system might work in the inventory management use case. Now, why I went over all of this is to kind of show you how agents can improve different parts of these phases in order to reduce time and also make the system a little more adaptive, right? So, how would an AI agent handle the same task given the capabilities of today's AI models? Is in the design phase itself, you could make this. Remember, we started saying that if the stock count is less than a given threshold value, then you're going to create a new order and notify your supplier. You could actually make this threshold value itself very adaptive, which means that you could use, planning and memory components of the AI agent to set dynamic thresholds based on the historical demand. A human doesn't have to always go here and keep changing that, because sometimes it's possible that maybe during holidays the stock counts reduce much faster as compared to normal days. And this AI agent can actually look up a bunch of previous reports to understand what the threshold value should be and how often it should be changed, right? You can make that threshold itself very adaptive in a sense. And whenever you're creating the order itself, then in order to choose which supplier will be used for this particular order, you can use the tool usage capability for AI agents, where it can identify suppliers with the best prices for a given item, instead of hard coding the suppliers that the order should be sent out for. And in the execution phase itself, remember we went over these three steps, which is retrieve, generate, deploy, and validate. You could do this also with the tool usage paradigm, right? In order to retrieve the inventory data, you could generate or execute code to retrieve the stock levels. And you could also generate the purchase order using some templates that have been already stored. The agent can look up memory in order to generate custom orders. It's possible that different suppliers have different ways in which purchase orders have been built, so you can generate custom orders based on the history, and you don't need to provide templates all the time, right? And in the monitoring phase too, in order to track performance, you can generate insights and reports that can be used for upcoming orders. The AI agent basically is backed by a AI model, right? And that can be used in order to understand um, the trends and insights and to resolve incidents as well. If these incidents have happened before and they have been resolved before, you can use that history, and the agent itself can use a runbook to resolve errors or maybe escalate it to the right ticketing team and things like that, right? So basically, in all of these stages, you can bring in some amount of intelligence, and that intelligence is backed by the components of the agentic pipeline itself, like planning, memory, tool usage, and those kind of things, right? So you can kind of see how you take a typical RPA system and augment it in a better way by using agentic pipelines beyond it. So, to kind of summarize what we have done so far, we understood how a typical RPA system works, and we also explained how you can bring in agentic capabilities in this entire pipeline. And to kind of summarize what we have spoken so far, a TLDR or too long did not listen would be RPA mimics human actions while agents mimic human thought, right? You saw that whenever we went over all of these values, these updates that you could do agentically, these were things that would that kind of penetrated into human thought itself, like how do I change this threshold value, or how do I identify suppliers who are giving me the best prices at this time, etc. So wherever there was a lot of hand holding and kind of predefined code, you could automate that and reduce the amount of human uptime by using agentic kind of frameworks, right? Now, you know that we moved from this paradigm of traditional programming to machine learning, maybe about 10 years ago, where we said, um, does this image represent a cat or a dog? Like a simple question like this. Traditional programming would solve this by saying that if it has whiskers and an ear shape or pointy or something like that, then return cat. Like you would write a bunch of if else statements. But in machine learning, we figured that you could just throw in a lot of data, get intermediate features, and the model would predict this, right? You didn't have to write this entire step by step explanation in order to make predictions. In a similar way, just like software engineering and machine learning are related in the prediction space, in the action and the automation space, RPA and AI agents are related, right? In RPA, you pretty much hard code, or you pretty much lay out the entire procedure. In the agentic AI space, you kind of allow the system itself to figure out, right? So that's kind of the that's the way I look at how RPA and AI agents are related. Now, as soon as I go over this kind of a philosophy, most people start saying, then if agents are so cool and if agents can kind of do everything that RPA does, plus reduce the human effort, why not kind of replace all RPA systems with agents? Like it would be much easier for us, right? And this statement is almost like saying, let's replace all code in the world with ML models. And all of us today kind of know that that would not be a good decision to make, right? Code or software engineering pipelines are pretty useful wherever they are, and there are some pipelines where ML is more useful, and so you probably want to replace it, right? And to add to that, some good basically the AI agents themselves don't really come with all so AI agents don't really come with all good things itself. They come with their own set of challenges. I also want to go through those challenges to kind of give you a overview of why it might not make sense to just go ahead and replace all all RPA systems with agentic systems, right? Now, AI agents, one, is a very new concept. And also remember that many people think AI agents is something that's completely different than generative AI models. But AI agents are pretty much Gen AI systems, which are wrapped around with, tools, databases, and are also prompted to plan. It's not like an entire different paradigm. And depending on how these systems are built, AI agents often call these AI models internally multiple times, and they make the cost visibility pretty low, right? Because you're giving them quite some amount of autonomy, it's possible that they call AI models multiple times and you're hitting costs that you wouldn't have hit previously. And The biggest problem with AI agents as of today is evaluations, right? Because LLMs or Gen AI systems are evaluated based on content, based on their generation. Agents must be evaluated based on their actions, which is much more complex and nuanced given how non-deterministic all these systems are, right? If you have to think about a chat system, you have to evaluate the chat system on just conversations and multi-turn discussions. But for AI agents, you have to kind of break down the problem into multiple smaller steps and see how good the agent is doing at each step, because only if it gets all the steps right, it will be able to get to the final right answer. Or sometimes it can also do some reward hacking, get to the final answer, but then it's missed out some, or it's messed up some processes in between. And if you haven't looked at it, it can be a huge pain in production. And AI agents also significantly increase latency due to the additional processes they have, like things like planning, memory, access of tools. All of this brings in a lot of operational overload as compared to just using very vanilla systems. And AI agents also handling novelty for these systems has been a challenge for a while now. Of course, systems are getting much better. The underlying LLMs that power these systems are getting much better, but then handling novelty still remains a challenge. And they also lack very explicit feedback loops for correcting wrong actions, leading to repeated mistakes, right? So AI models are inherently stateless, which means that if an AI model is performing, basically if an agent that's powered by an AI model is performing an action 10 times, and each of the 10 times it performs it wrong, it's not really getting that feedback unless you go and change the prompt, or you go and do something with humans intervention. So there is no explicit feedback loop here in order to learn it, right? And given the autonomy that it comes with, not having a feedback loop is kind of hard in order to go to scale. So, given that we know AI agents have these issues, um, look at it this way, right? RPA is pretty good at handling structured workflows, and it handles high volume, low variability tasks very well. And it also does it with good cost and time efficiency. Versus AI agents are good at very adaptive and decision making kind of capabilities, right? They can also use context to kind of understand much more than RPA systems understand. And they work with unstructured data, they work with text data, image data, and things like that. And RPA systems are pretty much rule driven, rule based workflows. Now, the kind of perspective I want to give you here is it doesn't always have to be an either or choice. You don't have to go into two different extremes saying that AI agents are going to entirely replace RPA, or the other extreme where you say that AI agents are so volatile, so I might just stick to using RPA. You can really think of them as working together symbiotically to achieve tasks, and that's where I bring about three different modes in which you can make these both work together, right? um, I call these agent takeover one, agent on demand, and agent copilot. And I will cover what each of these mean. And depending on the use case that you're working in your enterprise, you can see which one might be the best fit instead of going ahead replacing every RPA system with agent, or the other way around extremes, right? Um, Okay. A quick note here is that both agents and RPA are designed to automate repetitive human effort. But in RPA, you think about what repetitive actions can be automated, right? But for AI agents, you actually think about what repetitive knowledge analysis and data backed decision making can be automated, right? Remember the threshold example that I gave you in the inventory management. If you can get some knowledge or data to say how these thresholds can be changed, then you can use AI agents there. So this is kind of a nice mindset to think of where to use RPA versus where to use agents, and an entire system itself where each of these kind of fall together. So the first, remember, I went over these three different agent plus RPA modes. The first one was agent takeover. Now there are some systems where using RPA might be a little bit obsolete as of today, and those are cases where personalization is heavily required. Right? For instance, think about a customer support agent, and if you have very traditional RPA systems, most likely people are annoyed with it because it's so rigid. And you can use AI agents there to, use customer data to suggest solutions and to execute tasks. And there it might make more sense to outperform RPA's rigid rule-based approach, right? And it also depends on the complexity of the task and how many different queries these customers are coming up with. Because if it's a very simple workflow that you can put together as a decision tree, then it makes sense to probably stick to RPA itself. Also, personalization is one area where agent takeover makes sense. The other area is real time optimization, right? For instance, think of a supply chain example where you need to do real time route optimization. And agents are much better suited here because they can dynamically adjust routes, they can use real time traffic and weather data, etc., as compared to a very rigid RPA system with rule based assignments. So, two chunks where agents might be better to take over is one is personalization and the other is real time optimization. Agent on demand is another mode where you can bring in the agent whenever the RPA fails, right? It's more like a fallback for your RPA system. One example is the inventory management we're talking about, right? Now, maybe the RPA automates reordering when stock drops below thresholds, but you can bring in an AI agent on demand to handle discrepancies like conflicting sensor data or sudden demand spikes, etc. You can kind of set knobs in different parts of your RPA system to say that if something looks off, if something looks like it cannot be handled by a rule based system, then bring in an agent and that will use data in order to make outlier decisions, right? And in a predictive maintenance kind of a pipeline, you can use an RPA system to kind of schedule routine maintenance. Based on some predefined rules, but then you can bring in an agent on demand to analyze anomalies like unusual vibrations or temperature spikes, etc., to predict failures, right? You kind of are cutting costs here because you're using agents only for high risk cases, or you're using it only for outlier cases and not really depending on it for everything. The other mode that I brought up was agent co-pilots, where you can use agents for tasks that require knowledge analysis and data-backed decision making in all parts of the RPA workflow. Remember, I went over three different phases of building an RPA system, and you can actually use agents as co-pilots in each of these phases, right? For instance, in your design phase, you can probably have AI agents that analyze existing workflows and suggest automation opportunities like process mapping, design, and things like that. In your testing phase itself, which is probably a phase most of you would be pretty interested in, you can use agents to generate use cases, you can use it to generate test code and things like that. But your RPA system still remains the same. You're using co-pilots, agents, agent co-pilots in order to make the experience of designing and building an RPA system much better. In the execution phase, agents can help modify static elements wherever required, and in the monitoring phase, you can do performance analysis and help with self healing of these RPA systems. And what do I mean by self healing? Is just that you can have agentic systems to kind of get these monitoring logs and understand where are the places where I need to be making changes to the RPA system, etc. To kind of summarize, one takeaway here is as soon as you see a problem that has, an automation problem that has been historically using RPA systems, don't jump into this idea that I need to be changing it to an AI agent. And again, don't probably lie back saying that the system probably doesn't even need AI agents. Think of it from a perspective of what is the trade-off between my task dynamism versus my task determinism. How deterministic do I want my outputs to be versus how adaptive do I want them to be? And kind of look at your system with that lens and think of whether you want to use RPA only, leave the system as is, or do you want to bring in co-pilots, because co-pilots just help you in building AI systems. And then agent on demand is probably a very safe choice if you're transitioning into an agentic kind of framework, because agent on demand kind of lets you bring in agents only for highly outlier cases and things like that. And agent takeover is like when you want to completely swap it up. Personalization and real-time updates is one place where I think it might make sense to do an agent takeover. But just use this framework to kind of think whether I can stick to RPA kind of workflows or whether I need to move to agentic workflows. Having said that, this is the end of my session. I think I am right on time. Thank you so much for attending this session. I write a lot on LinkedIn. So if you want to connect, feel free to scan this QR code and you can find my profile. Thanks for giving me the opportunity to talk today.